Hello, everyone. Nice to be here. And I'm going to talk, of course, about LLMs, but also about old-fashioned bird-style retrieval models, and how I think that both are still valuable and both can be used to help the other. I'm talking about information search. Well, you probably know all these applications. Search is basically everywhere. It's in retail, entertainment, traveling, work. So Google Scholar, we probably all use, although some of you use Zeta Alpha for that purpose. Email search, notoriously difficult task because email information is very unique and sparse, but let's not go into that. And the type of search that we all hate, or search engine that we all hate, not sure about your organization, but my organization has this really poor search engine on its website. Right, so search is everywhere. And now we also have this form of search, right? So you go to ChatGPT, GPT-4, and you ask a question, and then you get an answer. You can ask a follow-up question. And so before Jakub asked about, okay, who thinks this is human-like? Well, I said no, but actually in some aspects it is, right? It's extremely fluent. So like textually, purely looking at how fluent the text is, it's 100% human-like. But there are other problems with these models. I come back to them later. And one of the things is that by nature, they hallucinate. And that means that they produce information word by word, which means that every word is generated based on the probability that it occurs after all the other words in the context. So even if you do many tricks to make sure that your information comes from a given source, it's still probabilistic, the words that it generates. So by default, it will make errors, and I will show you that later. And in that sense, it's also non-human, because it was optimized for conversations. It was optimized for being likable. So it will always apologize for making factual errors. So here in this example, I said, well, the last fact is not correct. And then it says, oh, I'm sorry for my mistake. No, you're completely right. So on the one hand, that's great. It's very human. It's very natural, and also impressive how it actually connects this abbreviation in Dutch to this full phrase in English. So in that sense, very impressive. But it will always do this. So even if you tell it that it's not correct and something it is correct, at least this version of GPT then kept saying, oh, sorry, I apologize, right? So people are, of course, working on that. So we have this form of information, and this form of searching information is called conversational search. And this image comes from a book, an edition of Foundations and Trends in Information Retrieval by Hamid Samani. And this example already shows the potential that conversational search has in specific domains, like more complex needs, different from finding just one bit of information, but going into interaction to meet your more complex needs. So you could say that conversational search is a chatbot with information retrieval capabilities. And let me explain a little bit the methodology behind these traditionally. So there are two approaches that you can take if you want to make a chatbot with information retrieval capabilities. And the first is to do retrieval. So suppose you already have a collection of good answers, which was the old situation, and someone asks a question, you would just return one of the answers from the existing answer collection. So think about searching Stack Overflow. Many answers are already there. So if someone asks a new question, try to find the best matching or the most relevant existing answer from the collection. So this is quite common in question answering. And you can use the standard retrieval and ranking models for that. On the other hand, you can do generation-based. So you use generative models to reply to the user. And of course, this is very common in chatbot style agents and uses generative LLMs. And of course, then, as Jakub introduced, we now have hybrid models, and already hybrid models exist for a much longer time than now we're calling it retrieval augmented generation. And that is a specific term for how you use the prompt to actually present the retrieved information to the LLM, but it existed before, right? So the idea of, okay, let's first retrieve a subset of relevant information from our database and then generate a response based on that information, that has existed for longer. Right. So I would like to go into the challenges and opportunities of these things. Let's start with retrieval approaches. And so this is, okay, so I was told many of you actually represent companies. So can you raise your hand if your company actually has retrieval technology and uses retrieval models for stuff inside? Okay, good. So we all still use retrieval, right? So we have an index of information, and we want to get relevant information, relevant passage from that index, from that database. And a lot of the information retrieval models and ranking models are based on BERT, so encoder transformers, encoder-only transformers. So relevance label is learned in a supervised fashion between pairs of questions and passages, or questions and documents. Nowadays, we have interesting opportunities with generative retrieval. I'm not going into that. Maybe someone else? I don't know. Maybe Rodrigo? I don't know. No, also not. Okay. So this would be like, we now say the traditional way, although it's less than 5 years old, but it's the traditional way of doing ranking for text. But these BERT encoders actually have an important limitation, especially if you think of the at-work context. So the scientific domain, scientific papers are quite long, and BERT encoders in their default setting have a maximum input length of 512 tokens. And that has to do with the fact that the transformer encoder actually processes the whole input at once in parallel. And that's also its strength, because it can actually relate all the words to all the other words. But this is very like computationally heavy because it's quadratic to the input length. So these models have been like limited to 512 tokens. And if you think about scientific documents of, say, legal documents, which is also a domain we work in, those are always longer, almost always longer than 512 tokens. And even on the web, Wikipedia articles, for example, are also longer. And for a long time, a lot of the research in information retrieval was working, and still with passage level ranking, like the MS Marco, which is the most used benchmark set, is a passage collection. So yeah, when we are dealing with long documents and long queries, we have to do something with those documents and queries. And you might not really think of that from an academic point of view, but in practical context, it can be very valuable to actually use old-fashioned lexical rankers, like BM25. So who of you has heard of BM25? That's almost everyone, not completely everyone. So BM25 is a model that just works on occurrence of words. So let's retrieve the documents that have the words that occur in the query. It's very efficient, unsupervised, and you can use it for extremely long documents, extremely long queries without any limitation. Actually, we found that in the legal domain, it was much harder to beat BM25 with BERT encoders. That has to do with the limited amount of training data in that domain. You can also use automatic summarization, which was shown to be less successful. And then you can also do paragraph aggregation, which we also did. And that is reasonably successful. But it's all, yeah, you have to take an effort if you want to use BERT models on long documents. Then if you think about conversational search, utterances might be shorter generally than documents, but the conversation as a whole, it can be long. And users kind of expect from your chatbot that it actually still remembers the information from the beginning of the conversation. So if you use a BERT encoder on a conversation, you also have to do something. So you could either, the traditional way is, okay, let's remove all the things in the middle and only keep the beginning of the conversation and the most recent parts. But you can also use, for example, a model like a long former that can take a longer input context, although the attention mechanism inside a long former is not relating all the information to all the information. It has a sparsified mechanism. So you need to do some tricks there. One thing that we did, actually, my student Arjan, he's in the back of the room, is shift around some parts of the conversation to bring them closer to the part where you are actually doing the retrieval, right? So the goal here is the conversation. We're still doing retrieval, right? We're not generating anything. We have this conversation, and at each point, we try to give the user the most relevant answer from a huge collection. So we assume we have the answer somewhere there. And we did this for the legal domain, which is interesting because in legal question answering, there's a huge knowledge gap between the person asking the question, who is typically a layman, just some citizen having a problem, and the people answering the questions are actually lawyers, human lawyers. And some of them have much higher expertise than others. And Arjan actually used this, given the fact that some lawyers have much more expertise than others, to train a model to properly do this. So this was also encoder-based, BERT-based, long-former-based retrieval. So let's move on to the other type of model that we have if we are doing conversations, and that's the generation-based approaches. So at this point, you might already have like implicitly heard from my story that the retrieval approaches have, well, very positive aspects, but also some limitations. So on the positive side, in the retrieval model, you're always certain that what you retrieve is actually existing information, right? It comes from a source, and you can see what the source is. You can see who wrote it. Is it an expert? Where does it come from? On the other hand, these models are not very fluent, and you can only answer questions for which you actually have the answer there, and not necessarily tailored towards the exact question that the user asks. So it's not that interactive. And these are limitations that generative models have, conversational agents. They are fluent, they are more human-like, obviously, and they are much more tailored to the input. So the examples that Jakub showed is very specific questions can be answered with very specific answers instead of limited to the things that are in the index. But then there are also some problems. Hallucination was introduced. I will show you something about that, and also about bias in these models. But let me start with some examples of the positive aspects, the human-like and tailored. So this is just examples. So there was a master student who fine-tuned a dialogue GPT model for being more empathetic. So she had this data set where there are actually empathetic dialogues. And this makes it even more human-like. So this is not so much for information finding, but this would be like for support. And it works quite nicely. So after fine-tuning the model, it was really like giving empathetic responses to situations that the user described. However, another thing that happened, and she did this with a smaller version of GPT that was Dialogue GPT. At that time, you could still fine-tune that fully, right? But when she did that, actually, it appeared that the model had suffered from catastrophic forgetting about facts of the world. So instead of answering facts, it began to be empathetic again and sharing personal stories. So if you ask it a knowledge fact when Starbucks founded, then actually it would give the number as wrong also, but it would then tell a story about something that happened in their own life. So yeah, this shows that you have to think about what you optimize for, be careful what you wish for. And so one of the things is, this is similar to what happens in ChatGPT, how it's always very friendly and polite and saying sorry for my mistake. right? It's basically the same thing. It was optimized for that, for conversation, and not for information. Here's another example. So this paper is this week being presented on the Conference of Effective Computing, which is a little bit of a side field from NLP, but nowadays there's a lot of large language model stuff going on there as well. And what a student here did was actually asking ChatGPT, in this case, to assess the sentiment of a situation on 3 dimensions: valence, arousal, and dominance. And valence is how positive or negative is it? Arousal, how strong is the feeling? And dominance has a very specific meaning. I will show you next. So the model was initially already very good with very little instruction. So this was instruction tuned. So in the prompt, there was this information about assess this situation in terms of valence, arousal, and dominance. And then valence and arousal was very, very good immediately. But dominance, the model didn't understand well. So there was something added to the prompt. Well, remember, the meaning of dominance is, I don't know, how much control the person in the situation experiences. And then you see that the quality of the dominance estimates is much more secure. So this person is not experiencing a lot of control over the situation, right? So the person is like having a very anxiety attack here. So very, very low valence, very high arousal. So this was surprisingly well. And so this is a known benchmark. And so these models are now like ChatGPT with prompt tuning was much better on this than fine-tuned BERT models on the same task. So yeah, human-like, yes, very much. But now we go back to information search. This is completely different from information search, right? This is about human aspects. And for information search, we have the problem of hallucination, and it's more serious than people might realize. So there are these recent studies showing how bad it is. Like 25% of the generated summaries by this was still GPT 3.5 contains hallucinated information. And GPT-4 even is extremely poor at answering yes/no questions. And this is a serious issue in the healthcare domain. I was recently talking at a seminar with medical professionals, and more than half of them said they use ChatGPT for their work. And in healthcare, yeah, I would say can be a serious problem if the model hallucinates information. Especially because it was shown that the more specific the topic is, the more wrong the information will be. And it doesn't tell you, I'm not sure, right? So that's something that should be, I think that's something that people are doing now. It's like making an estimate of how sure the model is. Then there is bias in these models as well. So they were probabilistically based on what happens on the web. And so think about this task. It's a linguistic question. In the sentence, the paralegal married the attorney because she was pregnant. Where does the word she refer to? Well, this sentence is ambiguous. It could refer to either the paralegal or the attorney, but both is possible. So the answer of ChatGPT is the paralegal. But then, interestingly, now the person asking the question asked, okay, but why? Why do you think it's the paralegal? So some of you have already seen this example before, but please read what happens. So here, ChatGPT comes to the conclusion that attorneys cannot be female, right? So that's a very strong conclusion based on frequencies on the web. I mean, probabilistically, it would maybe be more likely that an attorney is male. I honestly don't know that, but probably that's more likely. That's okay. But then making such a strong statement, attorneys cannot be pregnant, yeah, that's quite severe. So bias and hallucination are a big problem. So I would like to argue that we have to bridge the gap between retrieval and LLMs and retrieval and generative models to actually enhance them both. So we can do that two ways. We can either help retrieval by LLMs. We can also help LLMs by retrieval. And so Jakub mentioned inparse. And inparse is actually one of the three ways in which you can use LLMs to generate synthetic data for retrieval. What we did was, instead of generating queries, what inparse is doing, we generate passages, answers. Actually, we didn't generate them themselves. Other people had already done that, and we used those to train retrieval models. And then the models become better than the models trained on inparse or only on the real data. So this was only a workshop paper where it was with ChatGPT, but we have follow-up work where we actually do it with open source language models, and that's currently under review. But it's very successful, especially if you throw in some reinforcement learning in the loop to make better data. You can also generate relevance assessments, and there's an interesting discussion going on in the information retrieval community about that and whether we should do that or not. So I think the paper number 3 here is interesting to read. And then the other way around, how can we use retrieval to help LLMs? This was introduced by Jakub. So I will quickly go through this. First, retrieve something, then generate a response. And the context in which we are using that now is task-based conversational agents. So in a context where you actually, your company is providing service to clients and having a chatbot to provide this service, you want to be sure that the chatbot is using the true information and not hallucinating anything. So one example here is from bol.com, one of the collaborators in that project. So yeah, how this would work, you could have a collection of information about the company, about the products, the retail database. And then once you get a user query, you first get the relevant information from that database and then add it to the prompt and generate a response, show the source, because then you can refer the client actually to the place where it is. So yeah, I think this will be a very good idea, a very good direction. It ensures more transparency. Also, as Jakub was introducing, it allows you to use proprietary databases, and it allows you to actually update the retrieval index without fine-tuning or retraining the LLM, which is very efficient. However, we've already seen some examples where the retrieval became the bottleneck, because if the relevant document is not in the top K retrieved documents, for example, in small collections, we were trying to do this for the Dutch law, for example, get law articles, then yeah, it's not going to work, and hallucination will then still happen potentially, but the chances are getting smaller. Plus, having a source there is actually helping the user find the true information. So this is my last slide. I would like to encourage academic researchers here. I think a lot of this, and this is interesting because on the slide where Jakub said, what are people now working on? Prompt engineering, hallucination, domain-specific, low resource languages. I think all of that is important. Well, for prompt engineering, I would make that a bit broader and say, okay, let's look at the role of the human here. Let's make these language models assistants to humans. So I think they are perfect in like making suggestions, suggesting text, suggesting style of text for creative tasks, etc., for making LaTeX tables, right? Perfect assistants. But for information search, I think we should be more careful at this point, and we should do more to make that better. And then also address things like privacy and security, and try to make transparent models where the user can find the source of the information. Thank you.